Assalamualaikum warahmatullahi wabarakatuh. Dear all participants in this Icosine 2020, I'm going to present about physico-thermal characteristics of hybrid briquette composed of coffee husk, coconut shell, and baking filter dust. This presentation will be in 4 sections. The first is introduction, material and method, result and discussion, and the last one is conclusion. Briquette nowadays use it in many purposes. For example, it's used in cooking. It's used also in barbecue to give special taste to the food, and also used as energy for heater. And in industry, it used for fire steam boiler. Materials and method. Materials used in this research are main material coffee husk, which collected from the plantation in Middle Aceh, and coffee shell from the local market in Lok Sumawe, and then baking filter dust from the inalum industry in North Sumatra. There are 2 adhesives used, starch pus and motor oil waste. The method to produce this briquette are: the first is all material including coffee husk, coconut shell, and baking filter dust, mixing with the starch pus and oil waste to make a briquette using a press of 141.7 bar hydraulic press. The briquette produced analyzed for calorific value, ash, moisture and density, and then pyrolytic and thermal decomposition, as well as morphological structure. Results and discussion. There are 2 pictures here. In the first picture, in the left hand side, you can see that all the material has the different calorific value. The highest calorific value is motor oil waste, and the lowest calorific value is starch. In the right hand side, you can see the product of briquette has the calorific value depend on the material and the adhesive applied. We found that the highest calorific value of the briquette is the briquette made of material with used adhesive motor oil waste. Relaxation. Relaxation is the increase of briquette volume without changing the mass of the briquette in a period of time storage in room temperature. You can see in the first picture, using starch as the adhesive, we found the lowest relaxation, which is 6 to 8% relaxation of the briquette. In the second picture, you can see that the use of the mixture of starch and motor oil waste, we find that relaxation is increased. In the last picture, when we use only oil motor waste as the adhesive, we found that the relaxation up to 11.7% in room temperature in 15 days of analysis. The pyrolytic properties is used to examine the energy absorbed or emitted by the sample as a function of time. This properties was examined using DSG instrument. We found that in the picture of 5A that the first peak obtained at 150 degrees Celsius with enthalpy minus 65.17 joule per gram. In the second picture, in picture 5b, we found the first peak at 103 degrees Celsius with the enthalpy of minus 180.4 joule per gram, and the second peak at 473 degrees Celsius with enthalpy of 85.32 joule per gram. Thermal decomposition refers to the mass reduction of a briquette during the combustion process. These properties analyzed using TGA, thermal gravimetric analysis, that we found that in figure 6a that the decomposition began at temperature of 418 degrees Celsius, where 25.4% of the briquette lost. In figure 6b, we found that the composition began at 256 degrees Celsius, where 32.5% of the mass reduced. And from this both the picture, we found that the reduction goes to continue up to more than 600 degrees Celsius. According to the research, we find that all the blend material produced to be a briquette met the SNI number 16235-2000, and briquette made of starch pass better than using motor oil in the relaxation process. Further research should be conducted using different briquetting pressure and molding in rectangular block, and analyze thermal decomposition up to 1000 degrees Celsius, and the combustion characteristics should be determined as well. Thank you very much.